Hi class, my name is Fernando Chavez. Today I'll be talking about Investigation 14, what you learned about geology. And so I'll be talking about the things that I've learned over this course and over this time period, about what I learned and what I found interesting within each lesson that we had learned throughout this class. So the first one that really caught my attention was plate tectonics. So plate tectonics were first um, they were first discovered kind of by a man named Henry Hess, which we can see in this picture right here. He's talking about how there is different layers of the planet, as how we have the sea level, then we have water, then we have the continent, the crust, and then we have the mantle right here. And so he's kind of one of the first people that we consider the founding fathers of plate tectonics. And over time, we started to learn that there was more than one tectonic plate. And over time, we discovered that we have a bunch of different plates that we consider as of today. As we can see in this diagram right here, it explains that we have around around 8 to 10 plates right here. I haven't counted all of them, but it shows that we do have quite a bit of plates that often scrape and pass by each other. The second thing that I found interesting was rocks and minerals, more specifically, the rock cycle. The reason why I found this interesting was because I typically thought rocks all came from the same process, which was just them cooling from magma. But the rock cycle kind of showed me a little different. That there's three different kinds of rock groups, and they all go through this kind of cycle that naturally all rocks will go through their geological process, and they typically go through this process in once in their lifetime. The third thing that I found interesting was igneous rocks. Igneous rocks were or are magma or lava cooled rapidly, and they're often rocks that are formed by the crystallization in that magma or lava. And so this is why we kind of have those grainy textures for granite and gabbro, is due to them being cooled rapidly, and then they get their coarse grain look that we're typically used to. So the third thing that I found interesting was sedimentary rock. The reason why I found this interesting was due to them being packed over time. And this kind of happens due to erosion, as we can see right here. The particles are carried by wind or water, and they'll go into the water over time, and they'll be first loosely packed sediments. But over time, as we can see, that they'll start to be closely packed, and then suddenly they'll enter the final phase, which is cementation, which they're then lightly packed sediments. And this is how we often get limestone, sandstone, and shale, where we can see with each of the rock that they have layers to them instead of just kind of a conglomerate look. The fifth thing that I found interesting was deserts and how they are often made. So deserts are often made due to a thing called desertification, which is a natural phenomenon that happens when soil is left exposed and wind blows away that soil, which then the soil is degraded and losing fertility and structure. And due to no rain, the soil is then baked, and the sun bakes the soil and then it cracks, and then the vegetation starts to lose over time, and then we sooner or later get to this process of where deserts are. And then the sixth thing that I found interesting was coastal environments. The reason why I found this interesting was due to the Coriolis effect, which is when this is a natural phenomenon that affects both wind and ocean currents by causing them to curve. And the reason why this happens is due to the rotation of Earth. If we didn't have this rotation, the wind path wouldn't curve to the left. It would just go straight down. And this is why we kind of have waves of today and winds. The seventh thing that I found interesting was glaciers, more specifically the snow line, since this is the lowest elevation where there is snow and ice year round. And then we typically see this right here in this glacier, where there's a fine line right here where we can see that there is a bunch of snow that looks like it hasn't melted over time. And this is often due to the zone of accumulation being pushed down. And then there's an equilibrium line right here, which then um, it equals out the zone of accumulation and the zone of ablation, which is getting rid of the excess snow. And so this is kind of where we'll see most of the snow line, and it's where it's deeply compacted. And the last thing that I found interesting was rivers and flooding, more specifically the wetlands, since they are the kidneys of the earth, and they are often used to break down pollution and stuff like that. And they often give us better water and cleaner water for the coastal, for more coastal wetlands than anything. And that's the things that I found interesting in this course.